We are currently drowning in an endless supply of fast answers, yet we struggle to find the deep understanding required to solve real problems. The code running our world is often buried under layers of jargon. This vocabulary often serves to protect the status of the expert rather than inviting the learner in. Ravindra Nayak's work operates on a different premise. To understand the future, we don't need bigger words. We need to return to simple truths. This approach reaches back to classical roots, stripping away assumptions until only the absolute, unbreakable facts remain is the core of first principles thinking. For a non-technical learner, hitting a term like backpropagation or deep learning creates an immediate barrier. The conversation often stops before it even begins. A mentor-led approach bypasses the formulas. Instead of starting with an equation, we begin with ordinary human experiences, things like breath, memory, or the way a ripple moves across water. A daunting technological system is just a series of simple truths that have been stacked so high we can no longer see the floor. Curious, how does a machine actually learn to correct its own mistakes? Imagine a simple instruction passing through 3 separate rooms. Along the way, it encounters noise and tired helpers. By the time it reaches the end, the message has become distorted. We don't abandon the instruction. We walk backward through the chain of people to investigate exactly where the distortion happened, so we can fix the path. This human process provides the blueprint for a neural network. The starting message is the input. The trust in each helper is the weight. The threshold to pass it is the bias. The decision to speak is activation. Adjusting the weights is correction. When something touches something else in this network, a ripple of movement travels forward. A neural network is a mathematical machine designed specifically to manage relationships and correct those ripples. If you can name what is going in, what is being done, and what is coming out, you realize a function is simply a transformation machine. But a transformation machine needs a reliable guide to measure and fix its mistakes with precision. We often meet the notation of calculus before we meet its meaning. In reality, it acts as the essential guide for navigating a moving world. Calculus exists because the physical world moves, shifts, and changes continuously. It measures the speed of a plant bending toward light, or the exact rate a cup of tea is cooling down on a table. Advanced math is the invisible language we use to measure the physical movements we already understand. Artificial intelligence loses its mystery once we break it into chunks. We stop looking at a mysterious machine and start seeing the individual components that make it work. Demanding clarity in simple language requires a more disciplined mind than hiding behind complex vocabulary. True intelligence does not attempt to eliminate all uncertainty from the world. It is the practice of carrying the responsibility of human judgment safely through that uncertainty. Seeing the mechanisms at play is the very first step on the ladder of translation. To build a resilient mind and choose the next honest action, you must return to the source material. The story concludes here, but the practice of first principles thinking starts with the next question you ask. You can find the materials to begin that process in the link below.